Welcome back to the channel. In today's video, we are going to solve a problem that comes up quite frequently in coding interviews, reversing an integer. The challenge we are tackling is to reverse the digits of a given 32-bit signed integer. But there is a twist. If the reversed number overflows the boundaries of a 32-bit integer, we should return 0. Let's dive into the problem statement and understand it in more details. Over LeetCode, this problem is present with the name reverse integer, and it is described as given a signed 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside of the signed 32-bit integer range, then return 0. Assume the environment does not allow you to store 64-bit integers, signed or unsigned. Now, what does it mean? It says that we are given a 32-bit signed integer x. Our task is to return the integer with its digits reversed. If reversing the integer causes the result to fall outside the range of a 32-bit signed integer, which is between minus 2 to the power 31 and 2 to the power 31 minus 1, then we will return 0. Here three examples are given. In first example we have input x is equals to 1 2 3, so the output will be 3 2 and then 1. In the next example we have x is equals to minus 1 2 3, the output will be minus 3 2 and 1. And in example 3 we have input x is equals to 1 2 0. In this case our output will be 2 and 1. Now let's ignore all the conditions and constraints and simply assume we have a number x is equals to 1 to 3 and we have to reverse this number. How we can do this? Somehow we have to get this last digit from the reverse of from the original number, that is 1 to 3, and append this number into our result number, that is reverse of x. Now again we have to get this second number, that is 2, and append this into reverse number. Similarly this process will continue and we will get this number as 321. Now how did this happen? You see that it happened in 3 steps. In first step we have to somehow get this last digit from the original number. Now the problem is this: how we can get this last digit from this original number. For that we have an operator named as modulo operator. When we apply this modulo operator over any number with 10, then it will always result with the last digit of that number. Suppose we are applying this modulo operator on 1 2 3 modulo 10, then it will result with 3. So our first step is completed. We have got this last digit. Now the second step is to anyhow add this 3 into reverse number. So how we can add this 3 into our reverse number? For that we can use a formula, that is reverse of x cross 10 plus this output number, here it is 3. It will help us to append this digit into reverse of x. So the reverse of, after applying this formula, the reverse of x will become 3. Now the third step is to anyhow remove this last digit from the original number. How we can do this? For that we have a simple operator named as division operator, which looks like this. And if we apply this division operator on any number, suppose we are applying this operator on 1 2 3 divide 10, it will always remove the last digit, that is 3, and will result with the remaining digits, that is 1 and 2. So all the 3 steps are completed. That is, we have first extracted the last digit, appended that digit into the reverse of x number and deleted the last digit from the original number. The process now will continue till we end the original number. Now we will get this 2 and we have to apply all the 3 steps. First, we will extract this 2 using this modulo operator. Then we'll append this 2 into this reverse of x number using this method. Then it will add this 2 here. And third step, we will remove this 2 from the original number using this division operator. Then it will remove this 2. Now again all 3 steps will be completed. Following first step, we will extract the last digit, that is 1 this time. We will append this into reverse of x using this method and will delete this digit from the original number using this division operator. So this is how we can get the reverse of any number. These 3 steps will help to get us the reverse of any number. But in our problem, we have certain conditions. The first condition was we need to take care of the sign of the number. If the number is negative, we can reverse the digits of its positive and then add the negative sign back to the end. The second condition which was given, we need to make sure that we reverse the digits. The number doesn't exceed the boundaries of the 32-bit signed integer. And if it exceeds the boundary of a signed 32-bit integer, we have to return 0. This is the code for this problem considering all the conditions given.